Okay, so how will our file encryptor work? Well, we're gonna create an out file which consists of the first 2 bytes is a random number between 1 and 65,536. Then we will have some padding. So if we have the random number 500, then 500 bytes of random bytes will follow. Then we have a 256-bit hash value, which will be our hashed password or hashed encryption key. That's so we have an ability to check if we have supplied the correct password or not. And then after that, all the contents of the file. And all of this will also be encrypted using the same key as is hidden in the SHA hash. And if you want to know how this works and why I need to do all of this, and I have recorded a special episode just for that, which I will also link to in the description. Okay, so let's start coding. As usual, I'm gonna start by defining the main, so I know what functions I need and when to do them, etc. And then I will start filling out those empty shells with real functions. I call it a function signature driven software design. Okay, so let's include stdio and all the other ones that let's put that in the H, by the way. So we'll simply include fse.h, and inside of here I will put all my regular include files. Perhaps we won't be needing all of them, and then we can remove them later on. But this way we don't need to pause all the time by looking at and finding these include files. String.h, and finally we also need our very own arcfour.h. And let's create a signature for our main int and char double star, like so. So how do we want to structure this? Well, we're obviously gonna need an arcfour instance and we are gonna need a key, an in file, and an out file. So char, or let's use our own integers. So int 8, let's make it easy. We can convert to our own when we need it. So char, and what did I need? In file and out file, and we're also gonna need an in fd and an out fd. So that's a file descriptor that we get from the open syscall. and we're gonna need an int 8 for our key. And then we need a couple of sizes. At least we need the size of the key. So let's do an int 16 key size. Like that. Okay, so if argc is less than, how many do we need? 1, 2 is less than 3. Then we're gonna print to standard error and tell that the usage of our binary file is in file out file. And the first is argv, and that's all. There we go. I hope the text size isn't too small for you. And then we're simply going to return -1. And now that we have enough arguments, we can assign our in file to argv1 and our out file to argv2. A little bit easier to handle, so we don't have to remember which these are. Next step is asking for the key. Well, let's open the file in file first, because we want to abort early if we're not able to do that. So in fd equals open, and we're going to supply the in file, and we're going to do read only, like this. And if in file is less than 1, printf std unable to open. No, let's not. Let's just do print error open and return -1. Okay, so now the in file is open. Let's do the same with the out file, by the way. So out fd equals open, because the file may already exist with the wrong permissions or be badly formatted, etc. So let's open both. Out file, and this is write only, and we also need create. So we create the file if it's not there already, And we also need permissions for the file, and that'll be 00600. So only our user will be able to read and write that file. And if this open operation fails, then fd will be the less than 1. And in that case, we want to close our inFD, and then we'll do the same as before. Like this. Okay, so now both our files are open. Let's read the key. So key, let's see. We need to have a function which reads both the key and the size of the key, right? But since we are reading the input from the keyboard, we can just do a string length on it. We need to improve this when we do our much more secure version in the future sometime. Okay, so key equals read key, and maybe we'll supply some kind of a prompt. Key, like so. And in this case, I will do an assert. So we also need to include all the assert stuff. And that is basically two things we need to include. Assert.age, and we need to define GNU source. If we don't define the GNU source, the assert function will still work, but another function, which is assert p-error, will not. But if we have that definition at the top of our H file, everything will work perfectly fine. Okay, let's see. Int 16, no, it should be an int 8 pointer, which we called read key, and int 8 here as well. So we need to basically read the key from the keyboard, and don't echo the characters to the screen. So let's see, we'll wait a little bit with that. We're gonna set our, what did we call the key? Key size. Key size will be equal to the int 16 of string length key. Now let's do char like so, and then we can change our key to int 8. Okay, so we have read the key. Next step is to start reading from the standard, no, the next thing is to start writing to the file. And the first thing is those 2 bytes of padding length, which will be completely random using a secure rand function. So we need that secure rand function. So let us let's create an int 8. Let's see. We need to have, let's do int 16, and we will call it the padding length, pad size. And the actual padding will be stored inside of that int 16, right? Yes. And we need an int 8 array for the actual padding bytes. Like so. So basically we will do something like pad size, or pad size equals secure round, and we need 2 bytes, something like that. Pad size I'm not sure if that's the best way though. It's a little tricky to store these kinds of data. Well, how do we store it? Because we're going to need it for an int 16 like this, but also for a long string of characters. I think we'll do 2 different variables. That must be the easiest way. So let's say we have an int 16 called pad size 16, and we also have an int 8, which is the pad size 8. That should be it. So pad size 8 will be equal to this, and pad size 16 will be equal to let's see, we need pad size 8 dereferenced. So let's have it's a lot of variables for the same thing. This can probably be done much better, but I don't care right now. I just need something that works. So pad size 16 equals the int 16 version of pad size 8, and the actual pad size will be pad size 16 dereferenced. That should be it, right? I think we need to print this out to see if it really works. Pad size %d, and this will be the int of pad size. This is a lot of different conversions. Well, let's see if that works. Right. Okay, so the only thing is we have the opening of files. This is commented out, and then we have this. So then we can start with this secure RAN thing. Yeah, let's do that. Close infd, close alt fd, free pad size 8, return 0, like so. Okay, so how do we create a cryptographically secure function for generating random numbers? There is actually a system call which is called, if we go into the urandom, I think there should be, get random, and that is a system call. So basically it returns the size of a buffer of a specific size. So if we say that we need 8 bytes of random data, we get that, perhaps, or we get less. That depends on the entropy pool. So basically this function uses a lot of different signals, like what has occurred since the computer booted up, all of different things. It puts in a big pool, which is called the entropy pool. So you can only create a finite amount of these random bytes between all the whole system. And when you run out of entropy, you just have to wait. So you can call this function with 2 different flags. First, we're going to call it with give us all that you have, and exit if you don't have enough. And if we don't get all the bytes, then we will call it again, but we will put a message to the user that this may take longer than usual. And then we'll call it with the other flag. Well, the alternative is that we don't use a cryptographically secure version of this, and I want it to be unhackable. So this is the stuff. We're gonna use this random, which means that it doesn't use a pseudo-random function, which is not good enough for cryptography. So we need to supply the random, and then it relies on the entropy pool. And basically we will let it be non-block the first time around, and the second time without the non-block. Easy as pie. So size, return value, and we have the buff and the size. And I think we can supply a null buffer to get it on the heap. Or perhaps not. Never mind, let's allocate that ourselves. And where is this? sysrandom.h. So let's go into our h file and include sysrandom.h. And let's see, this will return an int8 array, and we called it secure rand, and we just need to send number of bytes. Let's do int16. And let's create this function. So int8 array and secure rand. We will have an int16 size, and we need to have an int8 pointer. Let's start by checking the size length. So we need to assert that size is bigger than 0, and yeah, that's basically it. P will be equal to an int8 malloc of size bytes. We will assert P, or by the way, let's not assert P. If yeah, let's assert P. If we run out of memory, so malloc will start to fail, everything will fail anyway. So okay, so now we have our buffer. We need something that catches the return value. Size t and will be equal to get random, and it will be P. Perhaps we need to, no, we probably don't need to typecast that. and then the number of bytes, that size. Maybe we need to typecast this to a size t. And we need the flags. Right. So this, and then we have the same but non-block. So we need it to be random, and we need to be non-block. So this may return, let's do if n equals size, then everything is okay, and we can return p. And if n is less than 0, something has gone wrong, and we need to return 0. Else, it means that we did not get enough bytes, which means we will have to run this again. So we do f printf stdr warning entropy pool is empty. This may take longer than usual. Something like that. And then we call it again, n equals get random. And this time we need to increase the pointer p plus equals n. So we will supply p, and this time this value will be size minus the n bytes that we have already gotten, right? And we need to supply the grnd random, but not non-block. There we go. And if n equals size, we return, we need to deallocate, by the way. And right. Yeah. Then we need to save a copy. We can't free it if we have jumped it around. Well, we can just jump it back. That's better, actually. No, we don't know how many bytes. Okay, let's do it this way. No hesitation. So if n equals size, then we return start. If n is less than 0, then we will free start and return 0. And in all other cases, it has failed again. So we can simply do else here instead. And this should be our function. So if we call it with 2 bytes, like this, and everything is okay, we should get different result each time. Let's see if this even compiles. Nope. But when does it ever first time? Int main. Second argument of main should be char star star. What did I do? I forgot 1 star. We can't make the main a single star. There we go. 1 gone, a couple more to go, right? Open. Did you mean p open? No, I did not mean p open. That's a library called for noobs. Let's see. Open, what do we need? man2 open, what do we need? Okay. So let's include this FC, NTL, whatever. If in file is less than 1, comparison between pointer and integer in file. Where is it? If in file, if in FD, alt FD, this one was right. Int 8 padding, unused variable. Key size set but not used. Warning, unused variable. But it compiled. So let's see what happens. FSE. Yeah, we need to mock these files. Let's just touch in file. And let's do FSE in file, out file. 45938, 40950. Yeah, this works perfectly well. Great. Okay guys, let's create the read key function, which will be a quite simple function. It's going to read the key from the keyboard and The only thing we have to make sure is that we don't echo the characters to the screen. So the only thing we're gonna have right here is a prompt, and what do we need? We need a buffer represented by a pointer. So let's see, we're gonna return an int 8, so let's make this an int 8 pointer. And we're gonna, let's see, we need a temporary buffer on the stack because we don't really know how many characters to allocate. So let's say, let's do unsigned char. No. Let's do char, and let's say we have a max limit of 2048 bytes. Or that's a bit much perhaps, because the biggest size in a 2048-bit encryption system is 256. Okay. So let's make it 255. No, 256. Because as you know, this isn't the index. This is a number of chars that we want to allocate. So counting the 0, it's 256. Okay, so let's begin by writing the naive version of it that echoes to the screen. And then we will simply fix that afterwards. So how do we do with this? We don't have to make it so difficult. Let's just begin mem setting. I shouldn't call this argv buff. We're gonna mem set the buffer with 0, 256 of those. Then we are going to read from standard in, standard out, standard out. From standard input into our buffer, and we have to, no, we don't have to cast that. And we're going to read a maximum of 255. So we have room for the ending 0 as well. Okay, so now we have read one line. We need to remove the ending new line from the input as well. And we're gonna need an int for our, let's do an int 32 for our length. Or no, why should we just be as big as that? An int 8 should cut it, right? So size, and we'll simply just call string length on the input. Buff, and then we will, let's see, if we have A, B, C, D, That's the length of 4. And the indices will be 0, 1, 2, 3. And if we have a new line at the end, this will be index 4, and the size will be 5. So let's do an index as well. And index will be the size -1. So let's do let's point our pointer towards buff plus index, and let's zero that out like so. And then we will allocate our buffer. So this will be an int 8 malloc size. And if malloc fails, everything will fail. And if it works, we will simply copy our string to p from buff, and the size will be size, right? Or maybe -1, by the way, just to make room for everything. Okay, let's remove this. And did I forget anything? Yes, we need to typecast a little bit. So the size is an int 8. So we need to make this an int 8. No, wait. An int 8 like this. And we need to send we can send the buffer as is. Read buff, memset buff. Int 8 malloc. I'm gonna string copy to p from buff. I think this will work, right? Perhaps we need to cast this one. And then we'll simply return p. We also want to print our prompt. Let's not forget about that. So let's do printf, and then our prompt and the space. And we'll give the prompt right here. And then we need to flush the buffer because we are not ending the printf line with a new line. So we need to flush it manually. Standard out, like so. And here is our first version of that code. Did we create our... yes, but we didn't make this an int 8. this should be a char. Okay. So let's try it out without the echo, with the echo. Where are we? Key equals read key, third key. Yeah, let's try it. So make, okay, what is it? Differ in signedness. P equals buff plus index. So it's this line. So P equals buff, which is a char. So we need to do int 8 star plus index. Don't think that will be a problem. And P equals, let's try it out. Okay, we got a binary. Yeah. Okay, so let's try it out. In file, out file, key ABCD. We still have that pad size thing. We can remove that, but it seems to work. Okay, guys, let's end there for today, and we will continue this project another day. Don't forget to like and subscribe, and thanks for watching, and thanks for today.